So for today, on to Chapter 8 and sections 8.1 and 8.2. So 8.1 deals with triangles, but this time not right triangles. So either acute or obtuse triangles. Okay. And again, we want to find out all the information in terms of all the angles and all the sides. And so first off, we get in terms of law of sides. And so we got A over sine A is going to equal B over sine B is going to equal C over the sine of C. A over sine A equals B over sine B equals C over sine C. And so we're going to use this well, in order to get, given a triangle, we can find out the various missing parts of a triangle. Right? So, for example, given that angle A is 127 degrees, side A is 12, side B is 6. So I want to know what is the measurement of angles B and C and the measurement of side C. So this is a law of sine question. And the way you can tell it's a law of sines is, do you have an angle-side pair? So angle-side pair would be having side A, angle A, or side B, angle B, or side C, angle C. So we do have an angle-side pair. We got angle A and side A. So we got 12 over the sine of 127 is going to equal 6 over the sine of B. Well, that is a proportion. The way we solve a proportion is to cross multiply and divide. And if I do that step first, we get that the sine of B is going to equal 6 times the sine of 127, all divided by 12. But I don't care what the sine of B is. I want to know angle B. And so to get angle B, we get that angle B is going to be the inverse sine of 6 sine 127 over 12. So everybody should be able to plug that into the toy. And get angle B, and let's get this number to the nearest tenth of a degree. So to the nearest tenth, we end up at 23.5. How much? 23.5. 23.5 is correct. Should get 23.5, right? So, what's the measurement of angle C going to be?
Right in here. Yeah.
What does the total have to be again?
So, in a triangle, the sum of the angles equals what?
Yeah.
180.
180.
No, it's the sine inverse. 6.
So, angle C will be?
Divide that.
3.5.
Well, I was doing
angle C
29.5.
will be 29.5. Again, the sum of the angles in a triangle will equal 180. So once we know 2, we can find the third. It's going to be 180 minus the other 2, right? And so now that leaves finding side C. And so we use law of sines again. So 12 sine 127 is going to equal C sine of 29.5.
And how do we get 29.5 again?
Because 180 minus the other 2.
What did I do?
The 23.5 and the 127 I gave you in the start with. Right? Again, angle A plus angle B plus angle C has to equal 180 in a triangle. So now we're going to use the law of sines again, and this time we're going to find side C. So again, cross multiply divide. So C is going to be 12 times the sine of 29.5 over the sine of 127.
You already have 2 sides. Wouldn't you be able to just do the Pythagorean?
It's not a right triangle.
That only works for right triangle?
It only works for right triangles.
Okay.
Okay?
So it's 7. What are we rounding to?
Nearest 10.
So 7.4. Unless I've typed something wrong.
And you get 7.4. Okay? Okay. So you put that in, you should get 7.4 to the nearest 10. A over sine A, B over sine B, C over sine C. Okay. So make use of that law, and then we also make use of the fact that if you add the angles together in a triangle, you will get 180. Okay? And we're not using Pythagorean theorem because it's not a right triangle. So that's it. Right? But again, in order to do this, I need to have an angle side pair. So, for example, if I give you something like this, A is 31 degrees, B is 100 degrees, side C is 35.
So for the last question, when we're done, that final answer is C equals 7.4.
Yeah, so you got 3 answers.
Gotcha.
There's
Angle A, angle B, angle C. All right, gotcha.
Okay. All right. So in this one, did I give you an angle side pair?
No.
No, but we have it indirectly, right? So after all, I gave you 2 angles, therefore we can get angle C. Because again, the sum of the angles in a triangle is 180. So if I give you 2, you can tell me the third. So what is angle C?
49.
So angle C is going to be 49 degrees. Now we have the information we need in order to use the law of sines. So we got 35 over the sine of 49 is going to equal A over the sine of 31. Again, cross multiply divide. So side A is going to be 35 sine of 31 over the sine of 49.
You go back.
So you plug that into the toy.
23.9.
And we end up at 23.9 for that one. A will be 23.9. And then we basically do the same thing again. So we get 35 over the sine of 49 is now going to equal V over the sine of 100. Same process. Cross, multiply, divide. So V is going to be 35 sine 100 over sine of 49.
45.7.
So you plug that into the toy or the app.
45.7.
And this time you end up at 45.7.
And that's everything.
Right. So in terms of a triangle, the largest side will be opposite the largest angle. The smallest side will be opposite the smallest angle. In terms of the way it works. How about this one? Everybody take a moment. Tell me what the other two angles are and the missing side's going to be.
Is that as straightforward as I imagine it is?
Everybody should be done.
Are they all the same?
All you have to do for this one is just think about it a little bit.
Yeah, that's what I was saying. They're all 10 over
Okay.
60, right?
Given that information, what's the measurement of angle C have to be? 60 degrees. What's the measurement of angle A going to be? Where's the measurement of side A going to be? 10. Right, Nathan? No?
Is it like a equilateral triangle?
It is in this case. Because after all, it's going to be 10 over the sine of 60 is going to equal 10 over the sine of something. If you do it, and if you go through all that work, you're going to find out the angle of 60, which means the other angle has to be 60. So yes, this is an equilateral or equiangular triangle. All the sides are the same, all the angles are the same, right? So in this case, you don't even have to use the toy, you just have the thing. Okay. All right. Now, given a law of sines, however, there is a case where strange things can happen. Okay? So, if the adjacent side. Then you have three possible cases. So, if I have a triangle that looks something like this, okay? So basically, you're going to know this angle. You know this side, you know that side. So we're going to know this, this, and this. Okay? We're going to want to know the height of the triangle. And the height, h, is going to equal adjacent sine theta. So the three things that can happen are going to be dependent upon what is the relationship of the opposite side to the height of my triangle. Okay? So the three possibilities are, okay, if the height is greater than the opposite side, then no triangle. Right?
What do you mean no triangle?
Well, for example, if I find out, oops, sorry, wrong way. If I find out that the height is 12, but the length of this red piece is 8, can I make a triangle? No, it can't reach the base. Therefore, no triangle. Right? Second possibility is that the height is equal to the opposite side. Then we have one right triangle. Okay. So if the height is 12, the opposite side is 12, we get a right triangle. I have to take this. Hello?
That's the thing here is when it's a right triangle.
Yeah, it's right there.
English language.
Okay, sorry about that. All right. All right. And the third possibility now, in terms of all this, will be if the height is less than the opposite side, then, so if the height is less than the opposite, then two possible triangles. Again, this is all predicated that the opposite side is less than the adjacent side in terms of the given information. Right? So there are three possible things that can happen. No triangle, we have a right triangle, or you could actually build two things that match the information. Right? So let's look at an example. So let's say that angle A is 23 degrees. Side A is 15. Side B is 21. Good. Okay. So first off, my opposite side is less than the adjacent side. Because after all, 15 is less than 21. Right, Nick? Yeah. Okay. Good. So the first thing we want to know is the height. So the height, h is going to equal 21 sine of 23. So we want to know, what does that come out to be? That number turns out to be 8.2. So my opposite side is greater than the height, or my height is less than the opposite side, whichever way you want to look at it. And so therefore, given those three pieces of information, you could actually build two triangles. Yes?
Well, what makes the sides like the opposite?
Because here's my angle. This side is opposite that angle.
A is?
Yeah. Remember that side A is opposite angle A, side B is opposite angle B, side C is opposite angle C. The way it works.
But you don't use it in the equation? Because that's...
Well, we do use it to decide how many triangles are possible.
But why do you use the side of B?
Yeah. Because the height of my triangle is given by adjacent sine theta. So we got to first find the height, given this scenario. Okay. All right. So now, what's happening here in terms of my triangles, and why do we end up with two? All right. So let's sort of draw this out. We got, here's the base, whatever that may be. Angle A is 23 degrees. So this is A. Right? This, B is 21. So that's that piece right there. Right? We know the height is only 8.2. Right? So let's sort of put that in. Here's my height. That's h. Right? Well, side A is 15. Well, in terms of side A then, if I gave you this information, we could have that side A is going out like that, maybe. Okay? So that would be one way of doing it, is I could build this triangle. But the other way of doing it is, if you think of this as maybe being a hinge at that point, the other possibility would be that side A went like that. Okay? So we could get, given just those three pieces of information, and I said build a triangle, you could build two possibilities. You could build this one that goes out like that, or you could build this one that looks like that, given those three pieces of information. Okay? So now what we have to do, we have to find everything in regards to both triangles.
That makes me so angry.
Just wait till next week's test. Okay? So now we're going to use law of sines, like we've been doing. But now, we're going to have two cases. So, case one. We're going to have 15 over the sine of 23 is going to equal 21 over, we said that was B, right? Over the sine of B. We want to solve for B, so we cross multiply, divide, take the inverse sine. So B is going to be the inverse sine of.
Can you go back up?
21 sine 23 over so you play that into the toy. And to the nearest tenth, you get that angle B is going to be 33.2. Right? So that's angle B. Right? So angle C is going to be 180 minus the other two. So that'll give you 123.8. And then we could find side C. We got 15 over the sine of 23 is going to equal C over the sine of 123.8. Again, cross multiply, divide. So side C, 15 sine and you plug all that into the toy. This time you end up at 31.9. That's everything with regards to the first triangle. But there was a second possible triangle. Now, in regards to case 1, what was the first thing we found? Well, in regards to case 1 itself, what did we find first? Angle B, right? So it ends up that case 2 is actually not that hard because in case 2, you get that the new angle B is going to be 180 minus what we found in case 1, which was 33.2. So that'll be the new angle B in our second triangle. So that's going to be 146.8. Okay? And the given information is the given information for both triangles. So angle C is going to be 180 minus angle A and angle 23.
What is C?
10.2.
No, but how do you find it?
Well, because here's my angle B, right? Angle A is still angle A. Angle A is still 23. That doesn't change. The given information is the given information for both triangles.
So what was, wait a second.
Okay.
What was 180?
Right. So B is 146.8. A was 23. So my new angle C will be, yes,
Well, I still have a question. It's from,
questions from what?
well, how did you decide okay, so I got that H is 8.2, but, and I know that's less than side A and side B, but which one are you looking at that it's less than? Side
A,
Because it's
the opposite side. Opposite side means relative to the angle I'm giving. So, I gave you angle A, therefore the opposite side is side A.
So the H, the height is always going to be whatever side angle you have. Like that's what you're.
Okay. All right, so let's go back. Okay. All right, here's H, right? They're going to give you this angle, right? This will be the opposite side. This is going to be my adjacent side. Okay? Given the information, okay? Right? The height, after all, if you look about this is a, okay? In terms of what this is, if I look in terms, this is a right triangle, right? If I look at just in terms of this blue dashed line and this figure, that's a right triangle. This is the opposite. This is, in regards to this right triangle, H is here. This is the hypotenuse. My hypotenuse is the adjacent side in terms of given information, which is why we end up with this formula. Adjacent side theta. Okay? Now the question is how does the length of this red side, the opposite side, compare to H? That's where you get to the three possibilities. Okay? So in my case, my height was 8, my opposite side was 15. Right? Therefore, two possible triangles. Okay? Again, opposite means opposite to whatever angle I gave you. Okay? So side A is opposite angle A. Okay? So we got the information. First thing we do is find the height. This number is less than that number. Therefore,
That's what I was asking.
yeah. Okay? Therefore, two triangles. So we did case 1, got all the information. We're on case 2. We got the two angles
How'd you get angle C?
because B's 146.8.
Yeah.
Angle A is still 23.
It's gonna stay the same.
Right. The given is the given. That doesn't change.
And then we just
And so therefore, angle C is 180 minus the other two. So the last thing then is side C. And so we're going to have 15 over the sine of 23 is going to equal C over the sine of 10.2. So cross multiply divide. We get that side C is going to be 15 sine 10.2 over the sine of 23. Right? So you plug all that into the toy. And this time we end up at 6.8. So those signs. A over sine A, B over sine B, C over sine C. And again, in order to be a sine problem, you have to have an angle side pair. Well, the other law in this section is the law of cosines, which deals with the other possibilities. So now we have given all three sides, or given two sides and the included angle. Now, first off, let's do side, side, side. So we got, let's say that side A is, let's say that side A is 11. Oh, let's see, side B is 17, and side C is going to be 14. We have all three sides. So it's not a law of sine question, which means we get to the other law, which is the law of cosines. So, law of cosines is this. C squared equals A squared plus B squared minus 2AB cosine of C. Or, and I'll give you all three variations of that. I'll say the same thing. Like C squared, the next one will be B squared equals A squared plus C squared minus 2AC cosine of B. Or A squared equals B squared plus C squared minus 2BC cosine of A. Those are all the three variations of it. Right. So let's solve this problem. Again, we want to find, given we got all three sides, we want to know the missing angles. Right? All right, given, first off, given all three sides, thou shalt find the angle opposite the largest side first. Right? So, given side, 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 thou shalt find the angle opposite the largest side first. We have to do that first. So let's write down our problem again. It was 11, 17, 14. A was 11. B was 17. Right. So, given that information, we need to find what angle first? B. After all, given those three numbers, 17 is the largest number. So let's start plugging away at it. So we're going to get that 17 squared is going to equal 11 squared plus 14 squared minus 2 times 11 times 14 cosine of B. So now it's a matter of starting to number crunch all this out. So 17 squared is 289. 11 squared? 121. 14 squared? 196. 2 times 11 times 14. What was that?
308.
308. Okay. 308 cosine of B. Okay. Okay. Well, what is 121 plus 296?
190. 317.
What is that?
You said plus 296.
196, sorry. So 121 plus 196 is how much?
317.
So this will be 317 minus 308 cosine of B, right? Okay. All right. What's the next step?
289 minus 317.
Okay. So the next step is we need to bring the 317 to the other side. Okay. Okay. So the opposite of adding is to subtract. So we're going to subtract 317. So 289 minus 317,
-28.
negative 28. So we get that. Next step would be to divide and take the inverse cosine. So angle B is going to be the inverse cosine of negative 28 over negative 308. If you want, you could just drop the negatives, because after all, a negative over a negative is a positive. So I don't need to plug those in. I don't want to. In terms of that part.
So it's 85. 84.8.
Okay. So given we've been doing things to the nearest tenth, we're going to say that this is 84.8. Right? Right. Now the thing about a log cosine question is you only have to use log cosines one time. Because now
You have an angle side.
we have an angle side pair. Right? We now have the angle side pair. We have B and B, right? And so now we can find the other information by using log signs. Right? So for this one, it doesn't matter which one you do next. Right? So now, once we got this, now use law of sines.
So you could use law of cosines, it would just be stupid.
You could, but law of cosines is much more work.
Right.
Okay?
So it would be stupid.
Yeah. You could. Right?
Check your work.
Alright. So now we can use law of cosines. So we got that B was 17. So we get 17 over the sine of 84.8 is going to equal, let's do A. A we said was 11. Again, you could do either one. I mean, whichever one you want to do, it doesn't matter at this point, for this point. Right? So I want to solve that for A. So again, we cross multiply, divide, take the inverse sine. So angle A is going to be the inverse sine of 11 sine 84.8 over 17. So you plug that into the toy.
Why do you use the inverse sign? Because you're getting a base.
We're finding the angle. Whenever we want to find angles, we use inverse sign.
So it's 40.1 degrees.
So that comes out to be 40.1. And of course, we can then find the third angle because the sum of the angles has to be 180. And so therefore, the third angle is going to be 180 minus those two. Okay. So, given all three sides, we use our cosine. The other possibility then, the other scenario is given this. Everybody got this before I switch page? So now given this. Let's see. Angle C is (100 degrees). Side A is 12. Side B is 20. So, given this scenario, given side angle side, which is what we have here, thou shalt find the angle opposite, find the side opposite the given angle. Right? So given this scenario, so given side angle side, thou shalt find the side opposite the given angle first. Right? Which means in this case, we're going to find side C first. Okay? So we're going to first find the side. So we're going to plug it in. So we got that C squared is going to equal 12 squared plus 20 squared minus 2 times 12 times 20 cosine of 100. Now it ends up that this is easy. Much easier, less work here. Because all you have to do on the toy, provided you know how to do this on the toy, is I'm going to just say that C is going to equal the square root of that entire thing. Right? So you should be able, on the toy, plug in that C, just do the square root and put all of that underneath the radical. Okay? Because I don't care what any of the intermediate numbers are, in this case. The toy should be able to handle this.
26.13.
How much?
I got 26.13.
Yeah, so nearest 10, I get 25. Right? Everybody should be getting 25 for that?
Yep.
You end up at 25.04. We've been doing nearest 10. So we would go with 25, right? What's you doing? Change the number?
I went 2 times 12 times 20, or 2 times 20 times 20 instead of 2 times 12.
Okay, that would do it. Okay, all right. All right. So again, this one, we can put all of that in the toy directly. Okay. All right. So we get side C is 25. Now, for this one, however, there is a second thou shalt for this scenario. So the first thou shalt is thou shalt find the side opposite the given angle first. Okay? But then there is a thou shalt number 2 for this particular case. And that is thou shalt find the angle opposite the shorter of the 2 given sides.
This is still a side angle side.
Yep. So side angle side has 2 thou shalts. Right? So given my problem then, we would go back and say, okay, that would mean I have to find angle A next. After all, 12 is smaller than 20, right? Therefore, we have to find angle A next. But now we do have an angle side pair, so we're back to using law of sines. So we got 25 over the sine of 100 is going to equal 12 sine of A. Again, cross multiply divide, take the inverse sine. So angle A is the inverse sine of 12 sine 100 over 25. So you put that into the toy. And that gives you 28.2. And then, of course, the last angle can be found because, again, the sum of the angles in a triangle is 180. And so angle B will be 180 minus those 2.
So angle B.
So that'll come out to be
51.8.
how much?
51.8.
51.8, right?
180 minus 1. What was it? 51.8?
That's what I heard, right? 51.8? All right. The other section then deals with polar. So a couple handouts in terms of polar graph paper. If you want, you can always make copies. You can also find online free polar graph paper. Actually, 2. Remember. So polar graphs. So polar graphs are in terms of a radius of a circle r and an angle. Right? So polar is in terms of r and theta. Whereas xy graphing, right, tangent coordinates, are in terms of x and y. Okay? So first off, in regards to polar graphs, So there, we got polar graph, okay? The one I gave you has a few more increments. The major spokes on that one would be your 30, 60, 90, and so on, in terms of that graph paper, right? So polar coordinates are given in terms of r and theta. So polar coordinates are in terms of r and theta. Right? So for example, given my graph paper here, let's say I wanted to plot the point 360 degrees. So in terms of my circles, I could say this is one with a radius of 1, this would be 2, that would be radius 3 on my increments. So 360 degrees, my point is right there. Okay. Radius of 3, 60 degrees. Plot the point. Okay. Okay. I get my point. Well, 360 degrees, right? Okay. Now 360 degrees would also be the same thing as saying 3 negative 300 degrees. Because after all, going this way is positive, going this way is negative, and if I go 3 negative 300, I end up at exactly the same point. Right? So that is one thing different about polar coordinates and rectangular coordinates. Rectangular coordinates, you can only do one way. Polar coordinates, I can do multiple ways. 360 degrees is the same as 3 negative 300. It's also the same as 3 420 degrees. They all give me to the same spot. Right? It's also the same as saying negative 3 240 degrees. Right? So negative, when you have r is negative, so 240 degrees is here. Here, but negative 3 means put the point on the opposite side. Okay? That's what the negative means. Means put it on the opposite side. Okay? All of those would be that same point on that graph. So polar coordinates can be written multiple ways. XY coordinates can only be written one way. So what we want to be able to do is, given XY coordinates, we want to convert them into polar coordinates. Right? So we want to convert from rectangular to polar. So for example, let's say I have the point 3, 4. Well, if I plot that on a rectangular system, over 3, up 4, it's going to be right there. I can make a right triangle, drop this straight down. Right. So the distance from here to here is 3. The distance from here to here is 4. How far is it from here to here? What's the length of my hypotenuse?
5.
A what?
Is it a 5?
It is 5. So the way I find r is going to equal the square root of x squared plus y squared. Right? That's r. Given an xy point, after all, it's just Pythagorean theorem, because r is the hypotenuse. So in my example, r is going to equal the square root of 3 squared plus 4 squared, which is going to be the square root of 25, which will be 5. Right? Right. Now the next piece I need to know is the angle theta. Well, theta is going to be this angle right in there. That's theta. And given that we know x and y, we got that theta is going to equal the inverse tangent of y over x. What that? So, in my example then, theta is going to be the inverse tangent of 4 over 3. Okay. So, to the nearest tenth, $53.1.
Yeah.
Right? Theta is 53.1. So my point is going to be 53.1 degrees. So we know the radius, we know the angle. Okay. So then the next thing is, can you convert from polar to rectangular? Well, you did that in that one question on your homework where they told you r was 20 and the angle was 280 degrees.
That was this morning, I don't remember.
Okay. So to convert the other way, so to convert from maybe polar to rectangular, we're going to have, and we use that in the one homework question, that x was equal to r cosine theta, y was equal to r sine theta. So if you think about the one we just did, if I do x equals 5 cosine 53.1 and y equals 5 sine 53.1, you ought to find out that those numbers basically come out to be 3 and 4, given that we rounded our angle a bit. Well, they should probably come out to be the x and y we had. Cool. Given our rounding. So convert, given a point, you got to be able to convert it back and forth between polar and rectangular. Okay?
What is the advantage of doing that?
Well, polar coordinates, actually polar, we don't get to it, but polar actually makes dealing with complex numbers easier. As far as with those. I can express a complex number in terms of polar coordinates, polar, and then multiplying, dividing, and raising to a power is easier. Much easier, actually, that way. Okay?
And do we do that next quarter?
Oh, let's see, next quarter we'll do calculus. Nah.
No,
But after all, calculus is totally different.
we'll never do it.
Okay?
But if we did want to do it,
Eh?
it would be so much easier.
But you think about, polar, you think about, and what polar is, you think about a radar screen. Radar screen. So you think about air traffic control, they're looking at a polar grid. Right? How far out are they from the airport, right? It's all polar. That's considered where they're at. Okay? All right. So you should be able to convert back and forth. Right? So in terms of our equations then, we got that r equals the square root of x squared plus y squared, okay? Which means then by default that r squared has to equal x squared plus y squared, right? If this is true, this is true, right? Because after all, this is Pythagorean theorem, right? We got x equals r cosine theta. Y equals r sine theta. And theta is the inverse tangent of y over x. Okay? Those are all the various equations. Okay? So, for example, then, we could also say, not only can we convert between polar and rectangular points, we also could convert equations. So it's something like this: 4x plus 3y equals 12. That's a rectangular equation. What would that be in terms of a polar equation? Well, we said earlier that x was given by r cosine theta. So, for r cosine theta, y can be replaced with r sine theta, and we get that.
Does I need to be solid?
Okay, now generally polar equations are going to be in the form of r equals. Well, what's common to both terms on the left? Huh?
But common to both terms on the left.
Yes.
R.
R. Therefore, r can be factored out. So r, 4 cosine theta, plus 3 sine theta, equals 12. Okay. Now that all means multiplying, right? R times 4 cosine theta plus 3 sine theta. So the opposite of multiplying is to divide. So r would equal 12 over okay. So we get that.
And that's the final.
That would be it. Generally, polar equations will be solved in terms of r equals whatever. Okay? All right? And then one last thing. In terms of polar graphs, one thing about polar graphs, unlike XY graphs, you can get some fairly interesting shapes. So, for example, let's say we wanted to graph r equals 3 cosine 2 theta. Okay.
3
Now, of course, the first thing we need in order to draw this graph is we need some points. Okay? And we need to work our way all the way around the circle in terms of this. So we need to plug in values of theta, and out of that, get the values of r. Okay? So now let's make a chart. The graph paper I gave you does it in increments of 30 degrees, so let's do that. So we got 0, 30, 60, 90, 120, 150. I'll get down to 180 for the first chart. Let's go here, 180, right? So we want to plug in. Right? So 3 cosine 2 times theta. So we're going to start plugging in and get numbers to plot in our graph. So the first one is going to give me 3. Right? The next one will be 1.5. The next one is the negative 1.5. Plug it in. The next one is a negative 3. The next one is a negative 1.5. The next one is a positive 1.5. Next one is positive 3.
Is this r equals 3 cosine 2 theta just like some example?
Yeah,
problem?
an example problem.
Okay.
Right? That gets us around the first half of the circle. So now we go to the other half of the circle, but we do have to go through all 360 degrees. So this is going to be 210, 240, 270, 300. 330, and then 360. So this will be 1.5. Negative 1.5. Negative 3. Negative 1.5. And then this should be back to 3. Right?
So when we have a problem like this, we need to do all of this.
Yep. You got to go all the way around the circle. Now, of course, for some of you, if you actually have a graphing calculator and you know how it works, that's the other thing, right? Graphing calculator 1. Do you know how to actually work the graphing calculator? Number 2. Graphing calculator should be able to do polar graphing. All right. So somebody got my chart written down? All right. Okay, I'm going to go and... So the first thing is we get the chart of information. The next thing is we want to graph that information. So let's do insert. And put my graph back in. Okay. So again, we say that our circles go 1, 2, 3. So 0 degrees, my point was where?
3.
3. Right, 30 degrees, we were where?
1.5.
What?
1.5.
1.5, so that's going to say it's roughly there. 60.
Negative 1.5.
And negative 1.5?
Yep.
Right. Here. Right. Next one.
Negative.
90.
Negative 3.
Negative 3. 1, 2, 3 down here. 120.
Negative 1.5.
So here. 150.
1.5.
Okay. 180.
3.
Here. 210.
1.5.
240.
Negative 1.5.
Okay. Let's see, where are we at? 270.
Negative 3.
Just up here. Okay.
Negative 1.5.
For 300, right?
Yep.
There.
330 is 1.5.
Which is here. All right.
360
Okay.
is
All right. So we started at 0, which was 3, right? And then we went to 1.5, right? And we end up, if we graph it, and we should get so we end up with that. You get a 4-petal rose. Right? When you graph that. Right? So polar graphs, you can get some interesting shapes in terms of the graphs. Okay? Now, for those of you who have your graphing calculator, you guys figure out how to do it yet?
No, it doesn't want to graph it.
What?
So it doesn't want to graph it.
It doesn't want to graph it. All right. Well, let me hand out the in-class thing for today. And then, those of you who have your graph paper, your graph, I can give you a quick tutorial. 1, 2, 3. 1, 2, 3. 2, 1. 1.